My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 530. In this lecture, we will try to understand history of neural networks and deep learning. This is continuation of my previous lecture, that is lecture number 529. So, just recall in my previous lecture what we were discussing. Deep learning in a nutshell is deep neural network, but people did not take Hinton. I discussed about Hinton in my previous lecture. Hinton too seriously. Of course, the way they have started, Hinton published his work. Frankly speaking, I didn't read this paper till almost couple of years later, because I was involved in academic work where I was still studying SVM's Random Forest Extra. Around 2007, 2008, I didn't read Hinton paper till 2008. So, not too much of hype around his phenomenal work, but things changed suddenly in 2012. This is watershed moment. There is a competition called ImageNet conducted by team at Stanford. Very popular competition goal is we create a very big data set of images. Data set, or I can say few million images, and the goal is to, it's basically an image data set where you have to detect what objects are there in an image. It's very hard problem. Till 2012, people using till 2012 people using existing algorithms. In 2012, something massive happened, phenomenal feat actually. In 2012, what happened was ImageNet competition had some error. Every year this competition is conducted, they get some error. In 2012, using deep learning or deep neural networks, a team using this large data set, using advanced computers, using modern computers with a lot of computational power, people designed a simple deep neural network which could beat all other algorithms by big margin. ImageNet is one of the one of the hardest problem in machine learning at that time. In 2012, ImageNet is one of the hardest problem in machine learning to solve, because given an image, detecting objects is not at all easy. It's a very hard problem around 2012. So what happened was using these modern data sets and computational power. In 2012, there is a seminal paper where people said, okay, we can do better than every other algorithms by huge margin. This result said made everybody take look at deep learning seriously. I started reading deep learning ever since I saw this phenomenal work in 2012. From 2012, lot of companies, especially large internet companies like Google, Microsoft, Facebook, Amazon, all these companies, even Chinese search engine like Baidu, all these companies started taking notice of deep learning, and they said, okay, deep learning may be the next big thing in computer science, not just in artificial intelligence, in whole of the computer science. And remember, these companies had lot of data. These companies are sitting on tons of data. Imagine the amount of data that Google has, Facebook, Amazon, Baidu. They have lots. They have lot of data. They have lots of computational resources. So they started developing the deep learning because they had both of them, isn't it? They have lots of data, they have computational resources, but because they saw this is promising in 2012, deep neural networks can beat classical algorithms by a huge margin. They started investing heavily. So they put their money, their data, their computational power behind this problem. And from 2012 onwards, it's been the golden days. I could call it as golden days of artificial intelligence. It's phenomenal progress. that happened in last 5 years, and I personally witnessed it. That's why I feel so energetic about it. You see tons and tons of research work, again funded by largest corporations in the world, and also by largest universities. Lot of people realized, some of the best machine learning researchers in the world said deep learning is the next big thing, and we all need to be taught of it today. If you notice, all these great companies, great applications, all these great applications, if you notice, any one of your voice assistant, you might have encountered, you might have encountered voice assistants like Apple Siri, like Microsoft Cortana, like Amazon's Alexa, Google Assistant. I used Google Assistant and Amazon Alexa on day-to-day basis. All of them are powered by advances in deep learning algorithms. They would have been impossible without advances in the last few years. Since 2012, all these advances that happened since 2012 have contributed to all of these great applications. Not just this not only this, your self-driving cars, Tesla's self-driving car, Google's Waymo. All of these are today powered by deep learning. Some of the greatest applications, even in diagnosis today, we have skin cancer diagnosis. Using smartphone cameras. All that are powered by deep learning. A lot of modern stuff, great applications that you have seen in last few years are all powered by advances in deep learning. But remember, deep learning, some of the core algorithms of deep learnings have been there for a while. There are algorithms like convolution neural networks, which are very new. Convolutional neural networks are there from early 1990s, but we didn't have data and computation. Today, the reasons deep learning taking over is, of course, there are lot of data, lots of computational resources. Third important thing, there is lots of new algorithms. There are lots of new algorithms. One of the best researchers in this hour have come up, but if I have to rate them, first one is lots of data, second one is lots of computational resources, third one is new algorithms. These are the reasons for golden days of neural networks, especially deep learning. This is very exciting area. I worked in a short while on various projects. It's magical. It's magical. So over the next few chapters, we will learn about neural networks. We will learn a classical neural networks. Classical neural networks. First, the old school of neural networks, which become very popular around in 1986. First, let's understand what they are. Let's also understand their limitations. Then we will come to multi-layer perceptrons, which are nothing but our current deep neural networks. We will learn a little bit of multi-layer perceptrons, some basic algorithms, and then we will learn CNNs, convolution neural networks, RNN, and these are some of the popular models of neural networks that we will encounter, and the existing and that extensively used in industry. It's going to be a fun journey. Please bear with me. It will be very, very fun experience. I will continue my discussion in my next lecture. We will try to understand how biological neuron works. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.